I want to find the derivative of f of x equals tangent of x using limit definition. So I'm going to find the limit as h approaches 0. F of x plus h is just tangent x plus h minus tangent of x all over h. We know that tangent of a plus b is tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. So I'm going to replace a with x and b with h and plug it back in the limit. So I'm going to have tangent of x plus tangent of h over 1 minus tangent of x times the tangent of h. And then we have minus tangent of x all over h. In the top here, we have a fraction minus tangent of x. My goal here is to get it under one common denominator. So I'm going to multiply tangent of x with 1 minus tangent x tangent h. Now I'm going to rewrite this. They're going to have 1 minus tangent x times tangent h in the denominator. And the first fraction has tangent x plus tangent h as a numerator. And then minus. So I'm going to keep this negative factored out. I'm going to ignore it for now. So keep it factored and just focus on tangent. We have tangent times 1, which is tangent. And then tangent times negative tangent x times tangent h. So that's going to be negative tangent squared x times tangent h. We have tangent of x minus tangent of x. Those are going to cancel. And then the minus is going to turn into a positive. So I'm going to rewrite this as tangent h plus tangent squared x times tangent h all over 1 minus tangent x times tangent h. We have tangent h in both of these terms. So we're going to factor that out. We're left with 1 plus tangent squared x. And here I accidentally dropped the h. So let's put it back in. Okay, and it's 1 minus tangent x times tangent h. And this h, we're really dividing the top fraction by h, which is the same thing as multiplying by 1 over h. So this is really the same thing as multiplying by 1 over h. So the h, you see how it's lined up with the denominator here? That's going to multiply the denominator. Now, a couple things happen. We have 1 plus tangent squared, which is the same thing as secant squared. And because secant squared does not depend on h, we can pull it out in front. So we'll have secant squared x times the limit as h approaches 0. Okay, next we can plug in h is 0 for tangent h. Tangent of 0 is 0. So tangent of x times 0 is 0. And 1 minus 0 is 1. So we're left with tangent of h over h. That can be simplified further. Well, tangent is sine over cosine. So we can say sine h over cosine h all over h. And again, here, because we're dividing by h, it's the same thing as multiplying by 1 over h. So the h could just come up here in the denominator. So we'll have secant squared x times limit as h approaches 0 of sine h over h. And then I'm going to break up the cosine as 1 over cosine of h. Okay, so secant squared is outside. We know that the limit of h as limit as h approaches 0 of sine h over h goes to 1. And then 1 over cosine h, if I plug in 0 for cosine, that also goes to 1. So it's just secant squared times 1, which is just secant squared. So the derivative of tangent is secant squared. And that completes the proof. Next, I want to look at sine of x. So if I have f of x equals sine of x, I want to find the derivative using limit definition. So I'm going to use limit as h approaches 0. F of x plus h is sine of x plus h minus f of x, which is sine of x, all over h. I know that sine of a plus b is cosine of a times sine of b plus sine of a times cosine of b. So I'm going to replace a with x, b with h. I'm going to rewrite this as cosine x times sine h plus sine x cosine h minus sine x all over h. Okay. This gets a little tricky now. So what we want to do is break this up into two fractions eventually. But let's focus on sine x times cosine h and then sine x. Let's do a little more work there. We can factor out a sine x because they have that in common. So we have cosine h minus 1 in parentheses all over h. Now we can break this up into two different fractions. We can have limit as h approaches 0 of cosine of x, and that's sine h over h, plus sine of x times cosine h minus 1 over h. Sine h over h is 1. Cosine h minus 1 over h is 0. So these are the common trig limits that we should know. And sine x times 0 is 0. So this whole thing is going to be 0. I'm left with limit as h approaches 0 of cosine of x. And because cosine of x does not depend on h, cosine of x is a constant. So cosine x is going to be my limit. So limit of a constant is the constant. So we conclude that sine of x, so the derivative of sine of x is going to be cosine of x.